Hello, Mark.
Hey.
Welcome to Pie and Coffee. Now, Jerry just left the screen. Perfect. What are you drinking? What are you drinking? So, Jerry, you just went off to get coffee.
Yeah. No, I just wanted to make an introduction, I just wanted to walk into the set.
There you go.
So, Jerry, what are you drinking?
Actually, this morning I've got an interesting one. I changed it up into the chai tea, but put some espresso in there. So it's a dirty chai is the street term for it.
Okay. Mark, you've got a drink as well?
I got a drink. I'm not a coffee drinker myself. I'm not a big fan of the smell or anything. So I've got just a hot chocolate here. I was going to do a Mountain Dew.
Good choice.
Me up a bit, but
Can you tell me a little bit about the process? How did you make your hot chocolate?
A packet dumped in a cup of water, put in the microwave for a minute, done.
Stir. That's how we do it on this show. Very, very high quality.
I'm currently traveling for business. I've already finished my coffee, and that came from that machine over there, and it was completely average.
That machine, I like
it. Maybe we should go for an introduction. Mark, do you want to introduce yourself?
Yep, I will. Will do. Name's Mark Houtz. You probably have heard now. I work for the state of Utah here in the United States. I work in the K-12 space, so I cover 30,000 students. I work not with one specific school district. I work with a bunch. So I cover 9 school districts and 4 charter schools, or 4 or 5 charter schools. I can never remember anymore.
Okay.
So, but I just do network engineering. A lot of the districts, I work with more of the rural schools that live on the Wasatch Back. So around Park City, for those that know Utah. I cover Park City and around the surrounding areas on the Wasatch Back. And so covering a bunch of schools and helping them with their networks and improving networks and stuff, and have some ties with Keith Parsons and Fernay. Fernay used to work in the state of Utah and the K-12 space as well. So we got some ties with him. So that kind of got me into the Wireland Pros.
I see. The plot thickens. I see what's going on.
So that's kind of what got me into Wireland Pro crowd. I've been doing Wi-Fi since about 2007 or so. Enterprise Wi-Fi in different capacities and things. So, but
the main reason why we wanted to have you on was to talk about some of the other things you're doing outside of the Wi-Fi space, which really piqued my interest since, I've been kind of, I don't know, at least doing some research, but not gone full in on anything like outside of really the Wi-Fi space in a while. But there's definitely some pretty interesting other non-Wi-Fi wireless technologies out there. You want to talk a little bit about some of the stuff you've been working with?
Yeah, we'll do. Here in the state of Utah, back about 5 years ago, 2017-ish, one of the IT directors at one of the school districts here in the state, and trying to solve a problem that's well known throughout education, that there's a lot of kids that don't have connectivity at home. And so he came up with this idea. He'd been watching the industry and heard different things about what was coming down the pipeline, and heard about private LTE and now private 5G, so CBRS. We actually originally were looking at doing it in the EBS bands, education bands here in the United States, FCC approved bands, but the FCC actually took those bands away from us and auctioned them off about a year ago. So we had to transition to just CBRS like everybody else. So we're doing CBRS so CBRS in the United States is 3.55 to 3.7 gigahertz bands. It's doing private 5G. We're doing private LTE, but we're testing private 5G in the band with different technologies. our main use case is reaching kids in the communities. So this guy kind of came up with the idea, and it's kind of caught fire as one of the main use cases for CBRS right now. Is especially with COVID, it became just became a big deal with COVID that all these kids at home weren't able to connect.
Can you just talk a tiny bit? Can you just talk a tiny bit more about the fact that the education bans? I didn't know that such a thing existed, and I'm also intrigued that it was then taken away. Can you talk about that for a moment?
Well, back, I think in the 60s and 70s, they set apart some bans for education space that was meant for TV broadcast. It was the 2.5 gigahertz, if I remember right. It's officially called EBS. There were some bands for it was TV space. Education used it a little bit, but it never really caught on. But it was a way for schools to broadcast out, a lot of higher ed in a lot of ways, but some K-12 to broadcast out television to their communities, so they could essentially create their own TV station.
Okay.
And so the spectrum has been allocated as education for years, but we weren't really aware of it because it was many years ago, nobody was doing anything with it. So it kind of just got forgotten about. And so we approached this idea, started going, well, we can run LTE in it. And actually this guy and several people at the state met with the FCC and tried to get it approved. But by that point, they'd already started the process where they started searching for spectrum that led to now the 6 gigahertz. It led to the CBRS bands and a lot of the C-band and all that stuff going on right now with 5G and all that. So with the sharing and all that, they'd already gone down this process and already had decided this spectrum is not being used by education, so we're going to take it away and auction it off. So they took it and auctioned it. So there's some schools around the state or around the country that have been able to keep their bands because they were actually using it, but for the most part we lost it. So
interesting. So is that a state by state type decision?
I don't quite remember exactly what the how it was allocated or taken away. I think if you were using it, you got to keep it. So I think it's county by county, just like CBRS.
Wow.
By county.
So, interesting. Yeah, I've got a lot to learn about CBRS, but that's definitely something that's piqued my interest. What's kind of the use case then for you around those bands, those frequencies? I guess beyond obviously the Wi-Fi type use cases. What are you seeing the use case for CBRS in your environment?
So CBRS big use cases. So the education is reaching the kids, but the more of the business side viewpoint, a lot of people are looking at it as kind of a pass point idea. LTE networks were created for voice. And so a lot of people are looking at the big use case for this is providing cellular connectivity inside of buildings that don't always have the greatest LTE or 5G connectivity, being able to serve a lot of the carriers. The carriers are kind of dragging their feet on the idea, just as they did with Hotspot 2.0 and Passpoint, but they're starting to come around and starting to see that this potentially could take a load off of them and provide them their maps will look even better because you can finally get some connectivity indoors. So
would this be the backhaul piece of it then? Is that what you're envisioning the use case for it? Like when you say to the, for the kids, as far as providing, is this for providing internet connectivity to their homes?
Yeah, okay. For kids at the backhaul, we're purchasing. It's CBRS operates at higher power than Wi-Fi. So you can broadcast out. We buy some, I think they're 30-degree angle antennas, just like the ones Verizon and everybody else has on their towers. Yep. And so we stick them on top of schools and just broadcast out in the neighborhoods. our furthest distance we've got is 5 to 6 miles.
Nice.
So you can get some quite distance with some of the narrow beams of antennas.
But is that narrow beam on both ends?
Yeah.
Okay, so it's not.
No. The device itself is basically just an Omni, so it can but it doesn't penetrate walls at distance. It's the mid-band spectrum, so it doesn't penetrate the walls at distance. So what we're doing is having the kids we're telling the kids to stick the cradle point in like a window in a certain side of the house and things like that to help reach some of the kids. So, and it's really not for every kid. We're not trying to connect everybody. We're basically, because we're getting some pushback from ISPs and stuff, we're extending the classroom. We're not providing internet. So this is filtered. You can't watch Netflix on it and things like that. So it's really geared towards education, very specific kids, and just reaching them at home. So trying to help cover a lot of their needs so that they aren't getting left behind. So
good. So let's talk about the CBRS Pi project specifically. Yeah. So obviously we've got the WLAN Pi project, and you've kind of taken that to a new level. You know, we focused on with the WLAN Pi project, you know, the Wi-Fi side of things, and especially now with the WLAN Pi Pro, Wi-Fi 6 and Wi-Fi 6E. So where does CBRS Pi fit in? Because I know you've got a Wi-Fi 6E, I believe, radio on there, right?
I actually last night put 4.
Put 4 Wi-Fi radios on it.
It's got 4 radios now.
Nice.
I played with it I got a device in yesterday, and so I was like, I'll throw this in for the call. But it's got 4 Wi-Fi 6E AX210s in it.
We'll be seeing another blog post about that soon, I'm sure.
I'll be posting about that soon. But cool. With the CBRS side, so basically what happened, where this came from, is I saw the occasional little post from you guys and from Adrian Granados and about it, and I had a tech retreat with some of the people in my group, and we were heavily talking about CBRS and all that stuff. And I saw the 6 gigahertz coming, and I'm like, nobody knows that this is coming in our groups. So I was like, it would be a good idea just to throw out a presentation together and stuff. And then I was like, well, I kind of need to be able to show something. So I bought just a Linksys 6E router. And then I bought a Android, the Pixel 6. I was like, I want to kind of show more than just, look, it works. So I'd heard about your guys' project. And so I decided I was going to copy it because I figured your guys' stuff wasn't going to be out in time. So I was like, I'm just going to go out and go build it myself.
I didn't think it was going to be out in time either.
Yeah, I believe that. Production is crazy. So, yeah. But so it took me, so I started down the idea. Luckily, I bought my Pi before the craze, when everything went crazy with getting them. But I started down the path, and it took me 2 months just to get the driver to work on the thing.
The driver for the AX210 or what?
210, yeah. So,
we know that pain.
So you bought a Raspberry? Was it just the Raspberry Pi 4, or did you buy a CM4?
It was the CM4. I saw a post about the CM4 from you guys and Adrian. So I was like, I'll buy. So I bought that. Went down that route. So
okay. And then which carrier boards did you get?
So I got the IO, just the Raspberry
Pi, the developer IO board. Yep.
Gotcha. So
that's what we started with.
Big honking one with lots of ports on it.
Yep. Big honking board with lots of ports on it, and half of the board was not being used by anything. So I'm sitting there with this device. I've got this AX210 that I can't get the stupid driver to work, and half the board is got nothing on it. It's got possibility for a Pi hat or whatever. That exact board right there. Yeah. So
Those that are
half of
just
that is
listening, I'm just holding up the compute module, like the official developer board, which is about twice the size of the board that we ended up with for the WLAN Pi Pro. But yeah, this has a bunch of inputs and outputs that we didn't really need for our particular project, but it's a great, developer platform because it gives you access to all the IO.
Just before you put that down, Jerry, where would the CM4 go if it had one? Just so
kind of right in the middle of the board or so there.
One thing I think that is mind-blowing with the CM4 is until you've handled one, you just don't believe how small it is.
Tiny. Thing's tiny.
Okay. So and
half
so
that
is the
board's
CBRS
unused.
Pi...
Uh-huh.
Go on, sorry.
So half that board's unused. Pi had options, and so I was looking at different options, and I was like, why don't I throw in looking at possibility of CBRS? So I started looking around and found a SIM chip that actually did 5G. And so I was like, interesting. I had a Pi hat and all that. So I purchased that and threw it on there and came up with this thing. So were you going to ask something?
I was going to ask, so this SIM... So you've got the Raspberry Pi developer board, you've got your CM4 sat on it, you've powered this stuff up, you've installed Raspberry Pi OS.
Yep.
Or did you jump straight?
I did Raspberry Pi OS.
Okay. And then you got a hat which uses the GPIO ports exposed on there. Were there any other jumper wires that you had to do, or was it just the hat sat down?
So the card itself, the 5G card, actually is used over USB. So it just uses the GPIO ports for power. All connectivity is through USB. So I can throw another hat on top of it and probably won't have any issues. It just needs USB connectivity. So I just had to plug in the USB, plug in the antennas, and we're up and running. So with it, it was the installation of the drivers of it was actually quite simple. It took me maybe an hour to get that working versus 2 months with the AX210.
And that's a 5G radio, you said?
Yep, 5G.
So for somebody that is less informed on the 5G side of things, how does that all work in comparison to putting in an AX210? Drivers aside, it sounds like drivers were more painful on the AX210 side, but getting up and running with a 5G, you've got to rely on the carrier side, right? So it's not just open. So what does that process look like? How did you get connectivity? Do you have connectivity on the 5G side?
So 5G, no. We're 5G cores in the CBRS world side of things. The cores are there, radios aren't. They're still in development on the CBRS side of things. So everything in CBRS is still basically operating in LTE. Solona at what WLAN Pros was using LTE still at the con. So it's backwards compatible with LTE, just like our phones and everything. So it will operate in LTE. So it's doing LTE right now. With our little group here in Utah, we already have a CBRS network. So half a mile from my house is a radio broadcasting in the neighborhood. So here in my house, I get like 12 megs down and like 2 megs up. So not the greatest speeds on it here at my house, but it works. So it gave me the ability to test it and just throw a SIM in and be up and running. So
if somebody like me that, to my knowledge, there isn't, that network available to me, how do I get started with something like this? Obviously I could build one of these CBRS devices, but how do I connect it to something on LTE?
You have to go the route. I would recommend the Solona route there, especially in the Wi-Fi world. Coming from the Wi-Fi world, they're kind of building their product to be more geared toward the Wi-Fi people, not the crazy LTE, 5G, 3G, PPP people. There's a lot of acronyms that have comparable names in Wi-Fi, but they are completely off the wall, and you got a whole new dictionary to learn of terms and different things. And so Solona, if you want to go down this route, I would recommend going probably with them instead of building your own, because there's a lot of different pieces that we're building our own. We've gotten different components and put them together and stuff, but outside of the business,
Is that what you guys are operating, is under Salona?
we're not. Salona came out after we had already started down the path, and but I've met with JR and several of their people, Ozer and several of their people about things, and what they're doing is awesome.
You're using a similar technology, but
Yes.
just through a different carrier.
Different carriers. Yep. We're doing
Gotcha.
a company called Cordis for our core. You have what's called the EPC core. That's basically kind of a controller, but it handles the SIMs. It's gets really in depth, more than your listeners probably want to hear at this point. If they really want to dig into it, go watch the Salona videos.
Yeah, I agree. That's been my source of most of my CBRS knowledge, which is very limited still today. But yeah, Salona has some great training videos out there. I've been trying to work through those as anytime I've got some extra time to do some training.
So, yep, they're probably your best bet to get started with this. I haven't got their equipment, so I don't know what their lead times or anything like that. If you at WLPC, they had their own core and radio. You got to build your own right there. Theirs is all cloud-based, so you don't have to buy the hardware for your data center or anything like that. So that's why they're a good place.
Remind me the licensing. So obviously for us that, typically are in Wi-Fi, we're used to the unlicensed, frequencies. But with CBRS, there is licensing, but I can't remember the terminology. It's some kind of like, I don't know, soft licensing or whatever. Yeah. I can't remember the terminology, like semi-licensed kind of thing.
So it's kind of like the 6 gigahertz AFC that's coming with 6 gigahertz. It's kind of, they're taking that same model, but applying it slightly different. So in the CBRS world, there's 3 tiers. So there's the incumbent, which is the federal government. Basically, it's the Navy, some fixed satellite, and then there was some wireless ISPs that were using it that had purchased some licenses. Most of the wireless ISPs around the country have moved back to, they've been brought into either the other 2 tiers. So really your incumbent is the Navy. So if you're along the coasts or a few key spots around the country, they're using it for fixed satellite. Other than that, it's free game for anybody. So the next tier is called the PALS, Preferred Access License, or something like, I think is what it stands for. So they're county by county basis. There was 80 megahertz of the spectrum. So it's 150 megahertz channel availability of spectrum. 80 megahertz of that spectrum was licensed to via auction. But if they're not using it, the whole spectrum's free game. So you can use the whole spectrum if nobody's using it. So if there's available channel, you get it. So the spectrum is controlled by what's called the SAS, Spectrum Access System, I think is what that stands for. And it's all allocated and controlled by the SAS. So what broadcasting everything, LTE 5G is all a very controlled bands. They're all controlled by the radio instead of our contention-based Wi-Fi. It's all, the radio says you're broadcasting, your turn. It controls how the spectrum is used. And so where was I going with that? It's controlled, and by controlling it, it can tell that device you can broadcast at this time, and you can have some different operability at the same time. So that's the second tier, is the PALS. The bottom tier is what's called GAA, or General Availability Access, I think is what I can't remember exactly what that term stands for, but that's anybody else. So it's basically open to anybody. So you have to have a SAS registration. So you have to connect to the SAS. So it does require that license to connect to the SAS, but beyond that, It's just by radios, have your core, and you're up and running. So anybody can do it. So
very good. Is that what you guys are operating under?
The school district that I live within, they actually have a PAL license. They bought
nice.
secondhand. A guy purchased a PAL and he just purchased it for the base rate and doesn't have tons of use cases to use it. He just was like, this is cool, I'm going to buy it. So we approached him and so we're using a PAL for this group or this district. Most everybody else is just using the general availability. So GA.
Well, this has been super informative for me. Hopefully other people appreciate this kind of stuff. But yeah, I'm always looking for new things to learn.
I have a question.
Yeah,
I don't know if I've missed something, but like, so what did the CBRS Pi actually enable you to do?
Okay, so originally I was just connectivity, just testing out connectivity. I wanted to learn about a client because I've been learning about the core. I've been learning about these other pieces. Clients, we were just buying Cradle points and it has a software and it does what it does. So I really wanted to start digging into what the device do. I was studying for the CWAP exam and looking at it going, well, you got your spec analyzers, you got your, you look at packet captures and different things like that. And I was like, I wonder how we can kind of mix that in there. And so the specific modem I purchased is a Qualcomm based chip. And Qualcomm actually opens up a special monitoring port. And so I can actually capture the air traffic off of that device. Most cellular traffic it's not open like Wi-Fi. Most everything's encrypted. The control and management plane, and data is all encrypted. You can't get the data at all. The management data plane or management and control planes are kind of set up there. It's all set up differently. And so I was trying to figure out how to get access to that. And this device actually allows me to capture some of those packets, see some of the air interface. As soon as I associate it to my network, all I see is traffic basically that is, I'm connected, here's my signal strength. I'm connected, here's my signal strength. That's all the traffic is just talking directly. It stops providing me access to outside things. But if I don't associate it, I get a lot of other traffic. So I get T-Mobile, Verizon, AT&T. I get connections from some of their traffic off of it. So I can see some of their stuff. It's nothing like I can't see data or anything like that, but it's like some of their controlled traffic. So like one of the things that you can see is their beacons. The LTE beacons. You can see I've gotten a few captures where from reading about it, it's the traffic I'm receiving is basically wake up, I have a message or something for you. So I have like a text message or a phone call or something for that. So I received some of those from some of the carriers. We're not operating the voice side of things. It's basically another application you have to turn on. We're not using that side in ours, so I don't get those on my stuff, but that's kind of what I'm capturing right now. I'm looking
more of an analysis tool then. It sounds like the CBRS Pi, like you're using it more for analysis, not as much for connectivity testing, or are you using it for that as well?
I'm using it for connectivity testing. Previously, we're just taking Cradle points or a phone and walking around with an app on your phone, looking at the signal strength is this right now. There's no really logging or anything like that available in the cheaper products. I'm sure the carriers have products that you can go spend thousands of dollars upon to buy and get all those things. And a lot of the management plane and all that stuff you can get sometimes with your core, depending upon your core and your radios. You can get it from that side, but in the field, it's a lot harder. And so this device is kind of giving me that. It's giving me signal strength in a log format. So I'm getting Wireshark captures with actual saying, this is my strength at this spot. And so I can go back to that instance in Wireshark and go, there's my thing. Potential is you could put that into a nice bar graph and potentially build out some cool things with it. So some ideas I've got. Other ideas. There was a blog post about a month ago. A guy did about some CBRS networks he's been running. And then he had some neighbors that were running one. In CBRS, because it's all controlled, timing is huge. So you have to have time, or it can some major issues. And so this guy was seeing some major issues. So he had this tool that he pulled out. And that device he was able to solve some of the issues with that device. Well, we looked at that device, and it's an $8,000 device, and they wouldn't even talk to us about letting us buy it. And so I was like, I wonder if I can build something like that. It's basically a spec analyzer, and then it shows what's called the PLMNs, which is basically the Wi-Fi, not best. It's kind of a mix between a BSSID and a name. And so it just kind of pulls that and basically shows you who's around you, and you can go find the device. Well, I'm like, we can build that ourselves with easy tools off the internet. So I've ordered a SDR radio, software defined radio, that I'm going to potentially put on this. So there's one that actually is a Pi hat that was just released called the Caribou Light that I've got on order. See if we can build some of that type of things into this on top of that. So
cool.
So some ideas.
Is that to give you some kind of spectrum analysis
Yep.
view? Okay, that's very cool. Yeah, I'm curious to see how well that works. If somebody's looking to get into this with a Raspberry Pi, either Raspberry Pi 4 or CM4, what kind of cost have you totaled up the cost for getting into the CBRS side of this?
So the modem itself is your most pricey point. There's the Pi. It's just like you guys, if you can get them right now, but depending on which model you get.
Are you sure the radio is the most expensive part? Because
depends how much you're willing to spend on the CM4 to get the compute module.
Yeah.
So how much is the modem? I think I've looked at them a little bit, and they're around like 70 or so, or is that not the same?
So the LTE ones, you can get, they're around $100 in there.
Okay.
The 5G one, the one I got, was $300.
Oh wow.
Yeah. So
Okay.
the 5G stuff is still really the only one I found that supports 5G and band. So CBRS is what's called band 48. So if you're looking for a product, look for band 48 or B48, then you'll know it's supported in the CBRS band. This is really the only 5G modem I've found that works with the M.2. There's built-in stuff, but there's nothing really do-it-yourself. This is the first one I found. It's about $300.
And which key was it?
It's M.2 M key.
Yeah, it would be
M
B or
key.
M.
Okay.
Yeah, it's M. So
Right. Makes sense. Using the
USB.
Oh, so how many? So is the hat that you bought just exposing an M.2 slot?
Yep, that's all it has.
Right. Okay. So got it. So the hat
Yep.
exposed an M.2 slot, B and M key, which is
Yep.
actually just USB, and then the 5G modem. Did it come with an antenna?
Yes. So I actually got the device right here. I got another camera here. It's not a great camera, but
I think we're gonna have to have like a whole episode on M.2 keys.
Yeah, absolutely.
Spend like a half hour talking about M.2 keys.
So these 5 antennas right here, those are your LTE 5G antennas.
Covering all the different
antennas
bands.
over here are my Wi-Fi 6 stuff. So I'm going crazy on this thing. I actually drilled the holes last night and put them a little too close together. So I was like, crap. And it's got a GPS module.
GPS,
on it,
yeah.
so. And then right here are my AX210s. So
Very nice. Now you just got to wrap that into a nice case, and you'll be good to go.
yep. So it's quite the beast.
So 5 antennas for the CBRS side or the cellular side. Like what's the reason for the 5 antennas? Are those covering different frequencies? Is it number of streams? Like
It's streams. There's depending on the modem. So there's actually two. So there's this one and there was another one. From both of them I got from WaveShare. Put it back to my face here. Both of them I got from WaveShare, shipped out of China. They have one of them has two antennas with the GPS port antenna, and then there was this one. It was like $30 difference. So I'm buying the better one. So I got the five antennas. I think it's for spatial streams. In the cellular world, they're because a lot of it's outdoors. They aren't doing so much the MIMO as we know in Wi-Fi. They're doing what's called massive MIMO, where they're just throwing tons of antennas at it. So a lot of your 5G antennas they're building, have like 32 radios in them. And they're going massive, tons and tons of radios in them. And so I think from my understanding of the 5 radios is to kind of help with distinguishing some of the signals from that. So
okay. Very cool.
So
well, I'm noticing my my cup's getting pretty low here, so that's usually a good indication that we're about at the time for this episode. What do you think?
Pretty good here, so I think that's a good idea. So,
well, I appreciate all your blog posts. I've been following those. We'll definitely link those in the show notes. Anything else you want to call out or kind of final words or anything for the listeners?
Just been grateful for what you guys are doing. I put WLAN Pi OS on it after WLPC. Prior to that, I was just running Raspberry Pi OS, and it was a pain in the butt. So you guys added a lot of good tools that are actually helping with my projects. So
it's good to hear.
We
went through the same pains you did with the drivers.
They're pain in the butt. Now it's just plug the thing in, it works. So
exactly, that's the goal.
So awesome stuff you guys are doing.
Fantastic.
Can't wait to get a Pi Pro one of these days when we get supply again.
Yeah, on that, I've shipped out a batch of them to the Wireless LAN Pro store. Matthew that manages that, so he should be receiving those actually possibly today, and then hopefully getting some of those up on the Wireless LAN Professionals online store here soon. So probably within a week or so, those should be hopefully available. Still a pretty limited run of them. So if you are interested in it, probably want to jump on that pretty quickly. I'm not sure how long they'll be in stock or how many back orders they already have of those, but yeah, I'm getting those to them as quickly as we can to at least have some stock available.
Cool. And beyond that, just you guys keep doing what you're doing. Awesome stuff you guys have been involved with. So
I appreciate it, Mark. Yeah, same here. That's what it's all about.
Yep. Community, right?
That's right.